We are going to explain the Open BIM Analytical Model tool. This training material is part of the European BIM-SPEED project. Open BIM Analytical Model is a tool for automatically creating high-precision energy models, which are then calculated in other specific thermal and acoustic analysis and simulation applications. Open BIM Analytical Model can be used for creating high-precision energy models, which will later be simulated. The tool can be used by architects and engineers who need to perform precise energy analyses and simulations, taking information not normally considered in a BIM model into account, such as thermal bridges. In the video, we will explain the following topics: importing existing BIM models, hosting and transmitting of data through the cloud, automatically creating a highly accurate energy model, exporting data to the cloud, which will then be imported to other applications.
The Open BIM Analytical Model application, developed by SIPE, is used to generate high-precision analytical models for thermal and acoustic simulations. Commonly used BIM applications are not able to generate analytical models with sufficient definition to carry out high-precision thermal and acoustical analyses. Even though we can define spaces that will be exported in the generated IFC, these spaces do not include sufficient detail in their definition to be able to carry out advanced simulations. Open BIM Analytical Model is able to import spaces defined by other programs and provide them with this information. This application is integrated into the Open BIM workflow via the BIM Server Center platform. The first step to follow to create the analytical model using Open BIM Analytical Model is to read a BIM model. This model can come from modeling tools like SIPE Architecture, IFC Builder, Revit, Archicad, Allplan, etc. This model must be exported in IFC format and linked to a BIM Server Center project. In the Import Assistant, we have to select the elements that we wish to import to Open BIM construction systems. Generally, the architectural model has to be selected. Once a model has been imported, the 3D view can be opened to check that the model has been correctly imported. Open BIM Analytical Model is able to automatically generate the analytical model. We will be able to review and edit this model later on with the editing tools in the top toolbar. To generate the analytical model automatically, we click on the Analytical Model button located in the Generate group in the top taskbar. This will open an Analysis Assistant, which allows us to select the spaces to be included in the generation and to configure analysis options such as generate exterior surfaces, generate edges, or generate the surfaces of the shading elements. Additionally, with the Use the outlines of the spaces defined in the IFC model option, we will be able to speed up the analysis in cases where the IFC model has this information. Generally, it is possible to generate the model leaving these options as default. Clicking on Accept will start the analysis process. The duration of this process depends on the size of the BIM model and the capacity of the computer. Once the analysis has been completed, we will be able to view the generated analytical model by clicking on the Show Hide Template button in the Edit group in the top taskbar. In the generated model, all surfaces of the BIM model will be visible as well as their edges. We control the visibility of the model with the Snap Options button in the Edit group. After clicking on it, a window opens that contains not only snap controls of all the entities by category, but also controls for visibility, color, and opacity of the BIM and energy model. This configuration can also be saved on the local drive to be used in multiple projects. We can consult the data of all the visible elements in the tooltips that are activated by clicking on the Show Information Text button in the top right toolbar, which is found in many SIPE programs. We click on any element of the energy model to open the Edit window of its properties. This option is useful for modifying any element after the automatic detection. In the Edit window, we see the space associated with the selected analytical element, the type of surface, the type of element according to its position in the building, its dimensions and layout. For this example, we use Open BIM quantities to estimate the prices of the adopted improvement measures. To continue editing elements, we click on Edit Templates in the Edit group. Then an assistant is launched to review the definition of all the elements of the imported BIM model, for example, allowing us to see their thickness and edit their type. Open BIM Analytical Model is able to define multiple groups of spaces in the BIM model. This is useful for generating a single model that can be imported into thermal analysis applications or acoustical analysis tools, since the grouping of spaces in both cases is different. We're going to see how to define new space groups. We click on the Manage button in the Space Groups area. We click on Add, and a window appears where we can create and name each group. Here, we find a library with all the existing space groups. Each group is made up of one or several spaces of the BIM model and has a colour and a reference or group name associated to it. Usually, creating a space group for thermal analysis where the thermal zones are defined and an acoustic model with the acoustic zones is all that is necessary. This information, integrated in the IFC, will be automatically exported to thermal and acoustical analysis programs through the Open BIM workflow. The generated model rarely contains geometric errors. If this occasionally happens, we can directly correct the surfaces generated by Open BIM Analytical Model using the tools in the Edit group. Finally, we export this information to BIM Server Center to use it in other programs such as the SipeTherm Suite or SipeSound.
Thank you for your attention.